Our ozone systems are units that are generating O3. O3 is 3 molecules of oxygen atoms all attached together. Ozone is that sweet smell that you get after or at the beginning of a thunderstorm that you smell outside, that little bit of a sweet smell that you get. Ozone is important because it's an aggressive sanitizer. Ozone at atmospheric levels attacks organics. And so ozone system is attacking the organics that could be in the water, in the storage tanks, in our plumbing, in our piping. And ozone at atmospheric pressures are unstable. So as soon as ozone is generated in that lightning storm, it slowly reverts back into oxygen. What we manufacture here at Norland International are 3 different models of ozone systems, and they're all just simply different capacities of ozones. What we have here is our OZ50 systems that are producing 50 gallons per minute of ozonated water. We offer the same package in a 25 gallon per minute system as well as a 90 gallon per minute system. There's 2 methodologies to ozonating water. One is a batch system where essentially you're taking a tank of water and you're ozonating that entire tank of water to some concentration of ozone, and then you begin delivering that water to your downstream sources. What we do here is we do what's referred to as a side stream ozonation system. And with a side stream ozone system, we're ozonating that water as we're delivering the water to our downstream processes. So behind me, we have 2 4,400 gallon tanks that, when they're full, is 8,800 gallons of water. And even in some bigger applications, it's really hard or difficult to ozonate that full batch of water before you send it to downstream processes. Here, we're taking the 8,800 gallons of water, or whatever your capacity is, and we're ozonating that water to a desired level as it's being delivered to your downstream process. All while sending a little bit of ozone back into the tanks to keep the tanks fresh with just a small bit of ozonated water within that tank to keep that organics and different film from growing inside those tanks. With our ozone systems, the ozone systems, as you can see here, are comprised of different components. We have a contact tank. We have a pump system, fuel pumps that are pumping the water through the different processes. We have a control system. We have an oxygen generator. We have an ozone generator, various readouts of pressures and flows. And then we have a small injection system and then a small monitoring system that is monitoring and controlling the output. The process that we're doing here is we're pulling from our storage tank, going through our pump systems that are a split system. Part of that water is going through a small injection system that's injecting the ozone into the water. That water is going into a contact tank that has a series of baffles in it that's forcing that water to change direction under pressure so that we have contact, we have the absorption into that water, and that water then is being delivered out to our downstream process, all while that ozone level is being monitored by the controller so that we can hit desired set points of ozonated water. What we're doing is we're taking an oxygen concentrator that's taking the ambient air that we breathe that has the CO2, the nitrogen, the oxygen in it, helium, all the different bits and pieces that are in the air that we're breathing, and we're producing a medical grade dry oxygen. And we're then taking that oxygen, that pure oxygen, and putting it into the ozone generator. And the ozone generator is taking that oxygen and we're producing little bolts of lightning within the ozone generator, which is slowly breaking apart small bits of the O2 and creating an O3 gas and an oxygen gas. That oxygen gas then, through a series of flow controls, is being injected. The ozone gas is being injected into a little Venturi system that is putting small amounts of ozone into the water as it's flowing into our contact tank and through our contact tank so that we build up a level of ozone in that water. Ozone is super critical in the bottled water process because now that we have ozonated water, that ozone is now cleaning our water, making sure that our water is free of any organics, anything living in there, bacteria, all the stuff you don't want to have in your water. We bring pure water into our tank. We want to keep it nice and pure and clean. We're ozonating that water. We're now sanitizing our water. We're sanitizing our contact tank. We're sanitizing our pipe. We're sanitizing our pumps that are delivering that water to our process. We're sanitizing our filler during that process. And we're sanitizing the bottles that we're filling, and we're sanitizing the cap that we're filled in. And ozone, as I said earlier, ozone at atmospheric levels is unstable. And so that ozone that we've built up in our water, as soon as we build it in the water or produce it, put it into the water, it slowly begins to break down in what's referred to as a half-life. And so that means that ozone slowly degrades by halves over the course of time. And what we're typically targeting here with our ozone monitor and control system is we're trying to be controlled between 0.2 and 0.4 parts per million, with an M, per million, parts per million, 0.2 parts per million of ozone per million parts of water. And what we're doing is that 0.2 to 0.4 is we're delivering that water to our filler, sanitizes our plumbing again, sanitizes our filler, but immediately after we fill and cap and secure that bottle closed, that ozone slowly begins to break down over time. And as you go to check your ozone at your filler, immediately at filling, you're going to see the 0.2 to 0.4 parts per million. But immediately after filling that bottle, it's now at atmospheric pressures. It's no longer under the pressure of being delivered to the filler. That ozone begins to break down. And over the course of 4 or even 6 hours, you really have a difficult time measuring the ozone because it's reverting back into oxygen. And after you wait that 24-hour period, you really cannot measure that ozone without really sophisticated equipment. Over the course of 48 hours, there's hardly any ozone left in that water at all. Again, as you look at the system here, what we're doing is we're controlling in and outlet pressures going into our venturi, creating a vacuum across the venturi. We're sucking that ozone gas and oxygen blend gas into the water stream under pressure that allows some of that gas to absorb into the water. That product then is being delivered out into our downstream processes. Again, the system's manufactured in 25 gallon per minute systems, 50 gallon per minute systems, and 90 gallon per minute systems. And as you may intuitively believe or think that, as those speeds go up, the system gets bigger, and as the system goes down, it becomes smaller. Thank you, appreciate your time, and have a great day.